Yesterday we actually went through direct proportion. I told you guys that direct proportion is not just when one quantity increases, the other quantity increases as well, right? I told you guys that they must both increase in the same proportion. Okay, so I gave you the example of Daryl working at McDonald's. He earns $11 an hour. So if he works for the first hour, he earns 11. The second hour, he should earn $22. Every hour that he works, he should increase his wages by $11. Okay, so that is the concept of direct proportion. Okay, we also did the quizzes, okay, yesterday. Some of you did very well for it. Okay, so today, what we're going to do is we are going to start with the new subtopic, inverse proportion. Okay, now in this chapter, the main concept that I want you guys to take away is that sometimes in life, not everything moves in the same direction. Correct? Not everything moves in the same direction. Sometimes when we increase something, the other variable will decrease. I give you an example, and the example is actually in this, in your worksheet itself. Okay? So, when you talk about speed and time, okay, when we talk about speed and time, Shannon, when we talk about speed and time, the faster we move, the slower, the more time we take or the lesser time we take to reach our destination? Lesser time, right? So for example, if you are going home, let's say you are from school, you want to go home, okay? The faster you walk, the less time you actually take. Okay? So we realize that there is actually an inverse relationship. Okay? The faster you move means the variable in terms of speed increases, but in terms of time it takes, it becomes lesser. Alright? So it is a little bit different from what we actually learned yesterday. Okay, so this concept you need to be very familiar with. Can you guys think of any other example? When you increase something, the other one will decrease. It's very easy for us to think about direct proportion examples, right? It's very easy, but indirect sometimes may not be so natural to us. Okay, but I can assure you it is everywhere. Okay, it is everywhere. Can anyone think of an example? I repeat again, the example means when something increases, the other will decrease. So I gave you the example of speed. If I run faster, okay, it means my speed increases, the time taken actually falls. Anyone else got any other examples? Anyone else got any other examples that you can think of? Yes, got any example? What is this? A water bottle example. What is the water bottle example? Come share with us. The more we drink, okay, I would say maybe the more time you spend drinking, maybe the volume of the water decreases. Okay? So yeah, I mean that's a valid example. Thank you very much. Okay, so that is an example of inverse proportion. Now, so in this example, let us look at this together. Julius, I thought you suspended. Sure, you're off road for suspension. Okay, please take a seat. Julius, can you sit here? Sit in front here. Come. How about in front of Kelvin? In front of Kelvin? No, here. Okay, come on, please focus, okay? Now take a worksheet. Okay, let us do this. Okay, let us do this question together. Now, this is a speed time question. I remember I told you guys before, right? Whenever you have a speed time question, what do I want you to draw up? Yeah, the don't steal things, right? So the DST, the triangle. So let us draw this together. Okay, can you draw the DST triangle? Don't steal things at the side. Okay, and let's try to work things out together. Okay? So over here, I can see, okay, if I want to actually find the time taken, you realize that there are several blanks over here. Okay? Let's work from the bottom up. I give you the scenario. This scenario is very simple. They say that Mr. Lee is driving to a town in Malaysia, which is 120 km away. away. Okay, so this 120 km refers to the what? Distance, speed, or time? Distance. Okay, great. Okay, so let us write down this is our distance. Okay, this is our distance. Now, I need to fill in my time taken over here. Right? I need to fill in my time taken over here. So what is the formula for me to calculate the time taken? What's the formula? Can you look at the DST? If I want to calculate the time taken, remember, I cover the time. What do I get? Distance divided by speed. Do we know the distance? Yes, we do. What is this? 120, right? Do we know the speed? No, are you sure you don't know the speed? Right, we do, right? The speed is over here. So what is our time? If we know our distance, we know our speed, then what is our time? Right? So I'm going to take 120 divided by 30. Okay, so I'm going to get 4. Okay, I'm going to get 4 over here. Can you fill up the other 2 by yourself? Can you fill up the other 2 by yourself? I repeat again, is the distance fixed? It is, right? The distance is 120. Okay, the distance from Singapore to the town in Malaysia is 120 km. So it is fixed. Okay, so what is the time taken if my speed changes? If my average speed changes, what is my time going to take? Okay, how much time do I need to take? Okay, the next one, I am going to have Honey. Okay, later I'm going to give you guys maybe another 20 seconds, but Honey are going to help me out with the next one. Okay, so do Okay, complete just the time taken, these 2 boxes only. Okay, if you forget the formula, look at your DST, cover the time. What is the formula? Okay, you got to try by yourself. Alright, okay, Honey, come help us out. Time taken is the distance divided by the speed. Right? So what is my distance in this question? 120. Okay, 120. What is my speed? 20. So what's my answer? 6. Okay? Huh? Answer is 12. The top one is 12, yes, okay? So she says it's about 120 divided by 10, so that gives her 12. Alright? So now let us take a look at this thing. Okay, so we can actually see here that when the speed, as we go down, the speed actually increases. Can you see that? As you go down the row, okay, or the column, sorry, the speed actually increases. But what happens when you go down here? What happens to the time? It decreases. Okay? So this one is what we are talking about, inverse proportion. Okay, the concept of inverse first. We haven't talked about proportion yet. Okay? But inverse means when something goes up, the other goes down. You know? Inversely. Okay? So when we say that something is inverse, we are talking about the opposite. Okay? So when this goes in a certain direction, the other goes in the other. But what about the concept of proportions? I want you to take a look. Okay? Whenever you take these 2 numbers, multiply with each other. You take the speed times the time. Actually, speed times time gives us what? Anyone knows? Speed times time gives us what? Distance, right? If you use your DST, it gives you the distance. Okay? Can you try by yourself? Can you take these two numbers and multiply by yourself? Can you see what you get over here? Can you see what you get over on the last column? Can you try? Just try first. I know some of you got an answer. Okay, I want you to try it out. Yeah, some of you already tried the first few already, then you determine that definitely it's all the same. Okay, but is it always true? I don't know. You try first? Yes. This is Miss Tam. Okay, you're going to be your new teacher. Okay? So everyone has actually tried. Okay, then I'm going to pick some people. Calvin, come help us out. Okay, let's look at the next one from the bottom. So it's x times y, so I'm going to get 40 times 3, this 120. Can you help us with the next one? What is the next one? What times what? Good. 30 times 4 is 120. So if you follow along this thing, you would notice that everything in this column, okay, everything in this column is 120. It is because the distance is fixed. Remember I told you just now the distance is fixed. Okay, so we can call this distance a, you remember yesterday I gave you a word, I say if something doesn't change. If something doesn't change, we can call it a constant. Okay, so in this case our distance is a constant. Okay, or more specifically, our x times y is the constant throughout. Okay, so we're going to call it the constant. Okay, it's the constant throughout. So when we say something is a constant, we know that it doesn't change. Okay, the value of it doesn't change, it's going to be fixed. Alright, now this one is slightly different, okay, from yesterday. Now, just to remind you yesterday, when I say that, for example, the variable y is directly proportional to x, how do I write it? I would say that y is equals to kx. Right? I would say that. But I just want to let you know that it is inversely proportional, okay? It's just going to be slight changes. Okay, it's going to be slight changes. The way I'm going to write it is no longer y equals to kx. I'm going to write it as y is equals to k over x. Okay, don't worry, later I'll give you some examples of why it is. Okay, I'll give you some examples. I'll give you a graph actually to actually show you why it is of that relationship. But this is the only change. Okay, the x is no longer in the numerator but the denominator. Okay? Now, let us try to graph out how does the graph of y equals to k over x will look like. Alright, so what I want you guys to do at the bottom, same thing. Can you use a ruler? You guys should have a ruler. Just draw the Cartesian coordinate plane for me. Okay? And label this as the y and this one as the x. Okay, so at the bottom, just do a quick label. Okay, I'm going to show you how the graph of an inversely proportional graph is going to look like. Okay, I'm going to show you, I'm going to prove to you it looks like that. Alright? Now, the shape of the graph, okay, the shape of the graph is going to look like something that you have never seen before. Okay, so I just going to tell you it's a graph that you have never seen before. Okay? And the graph is called a hyperbola. Okay, it's called a hyperbola. And the shape goes like this. Okay, the shape goes like this. Oops, why is everything gone? Okay, never mind, don't panic. Let's redo it again. Okay, so for those of you who haven't drawn, can you quickly draw your Cartesian coordinate plane? Okay, I have my y, I have my x, and I'm going to draw my hyperbola. Okay, so it's going to look something like this. Okay? Huh? No, yesterday in quizzes we actually did. Do you guys remember what kind of graph does the direct proportional graph looks like? It's going to be a straight line that cuts through the origin. Okay? So this one is different. Okay, this one is different. Okay? Inversely proportional graph is going to look something like this. Okay, it's going to look something like this. And the shape, we're going to call this a hyperbola. Okay? Now, how to actually show you? Okay, I'll just give you an example. Okay? So let's say my x, this is my x and this is my y, right? I'm just going to plot out a few points for you. Okay, so I know that when my x is 10, my y is 12. Okay, so I'm going to say, okay, maybe here, oops, I'm going to say here is, okay, I say here is 10, I'm going to say maybe here is 12. Alright, I'll just draw some dotted lines. And if I increase it to, let's say, 20, let's say I can make it 6. Okay, can you see that? If you were to try to plot out. The next one is when it's 30. Okay, if you draw some dotted lines, you will see that it is 4. Okay, and maybe let's do one more. Let's say when it's 40, this thing over here is going to be 3. Okay? So our shape, okay, our shape of the inversely proportional graph is going to look something like that. Okay, so if you were to plot out a graph, and if you get a shape like this, I need you to remember the rough shape, okay? It means that it is inversely proportional. Okay? But of course, generally, this is the shape of inversely proportional graph. Okay, but there are some calculations that you need to do. Okay, which I'll show you later to actually really prove that whether or not it is inversely proportional. Alright, okay, so this is it. I'm going to leave up here for a moment. Can you finish the graph? Riley, are you drawing? Okay, can you actually draw some, at least the basic shape of how the graph looks like? Okay, at least draw the basic shape of how it looks like. Alright, okay, if not, I'm going to move on to the next one for work example. Now, how do we prove whether, whenever we have two variables, right, x and y, how do we prove that these two variables are inversely proportional to each other? How? Remember I told you that there is this constant, right? There is this constant. A constant means that it doesn't change. So your value of x and your value of y can change. But if it's inversely proportional, there is one property that will be a constant. And if that property is always the same, is always a constant, then we can declare that it is inversely proportional. Okay, so what is it? Okay, if you flip up here, this one already gives you the answer already. Okay, can anyone tell me? Okay, what is the constant? What times what is the constant? What times what? I said what is the constant? What times what gives me the constant? Look at this question. The variable of what times what? What? The speed. Okay, and the time. Okay, so in this case it is x times y. Okay, x times y must always be a constant. Okay, so can you do me a favor? In your graph here, can you just come up with another row of x times y? Can you just draw another row out over here? Can you just quickly draw another row out? And I want you to just calculate, okay, the value of x times y. Juniors, can you please quickly do that? Okay, so can you calculate the value of x times y? So I show you the first one. These are corresponding pairs, right? Okay, in your table of values, these are corresponding pairs. I take 2 times 60, I get 120. I do the first one for you. Are you able to do the rest by yourself? Can you calculate the rest by yourself? Okay, can you calculate the rest by yourself? Okay? Can you very quickly calculate the rest by yourself? And if they are the same, what does it mean? I want you guys to think about it. Okay? So if the value of k times, not k, x times y is the same, what does it mean? Okay? Alright. So if you have expanded everything, Joy, can you help us the next few? Is it all the same numbers? What's the number? 120, right? So what does it mean? What does it mean if they are all the same? Joy, can you help us out? What does it mean to you? They are constant, okay? So if they are constant, what kind of relationship does x and y have? They are? What is this chapter on? What is this chapter on? Proportional. Right? So they are inversely proportional to each other. Alright? So that's how we prove it. Alright? Okay. So in this case, determine whether y is inversely proportional to x. Say yes. Okay, so they are indeed inversely proportional to one another. Why? Is because x times y is a constant. Okay? So we know that x times y is equals to 120 throughout. Okay, so we know that it is inversely proportional. In all the examples, we know that it is the same. Okay, but can you look at part B? Can you just extend this table of values at the bottom and then can you just do a quick calculation? Okay, can you just do a quick calculation at the bottom over here? And can you calculate the value of x times y? Okay, can you calculate the value of x times y? And can you give me your conclusion? Do you think that they are still inversely proportional? Yes or no, and why? Okay, can you try? I think some of you have tried already. You did it by yourself? Okay, good. Okay, those of you who haven't tried, can you please try? Not every single question, okay, all the same. Some of you calculate the first one, immediately you write everything as 20. Is it really 20 or not? Can you really lift your hands off the calculator and really try? Okay, really punch in the numbers. Okay, and see for yourself. Is it really 20? Okay, come. So for those of you who have actually tried, you should get, here you should get 20, next one is 32, next one is 36, 4 times 8, next one is what? What's the last one? 32. Okay, so is this inversely proportional or not? Why? Yeah, because the value of x times y is not a constant. Okay? For it to be inversely proportional, okay? The same thing like directly proportional. You cannot say, oh, when one variable increases, the other variable decreases. So definitely it is inversely proportional. No. There is the concept of proportion. Okay? There is the concept of proportion, yes. This is 36. 36 and then 32. Okay, so in this case, no. Okay, it is not. And the reason is because x times y is not a constant. Okay, it is not a constant means it's not proportional. Okay? Alright, let's go to the work example number 2. Now this is when there are some slight changes that you need to be very familiar with. Okay, yesterday we learned about how can we change a mathematical statement into a mathematical equation, right? So this is what we're going to do now also. But now we are introduced inversely proportional. Okay? The word inversely proportional. So how are we going to do it? Like I said, it is very similar to direct proportion. The only difference, excuse you, is you will have m is, so I still have the equal sign, k, but now it is not k times n anymore. It's k divided by n. Okay? So it will be k divided by n. So when it is inversely proportional, okay, the second variable over here is going to be in the denominator. That is the only difference. If it's directly proportional, it is just k times n. Okay, it's just k times n. Alright? So how about the next one? Okay, let's take a look at the next one and maybe some of you can help me out on the next one. Let's see. Tristan, your table is up. Okay, can you help me with the next one? This one is Q varies inversely to the square of R. I help you out the first one first. Square of R is basically R squared. Okay, so how are we going to change this into a mathematical equation of the same form? It is inversely proportional. Okay, come Tristan, can you help us out? How? Q is what? What mathematical symbol? Equals? Then don't know already, okay? If you don't know, can you look up here? What is the pattern? The second variable, is it in the numerator? Numerator, is it in the top or is it in the denominator, the bottom? You sure the variable n is in the top? The bottom, right? The denominator, right? Okay, so if I want to follow the same pattern, what do you think I'm going to put over here on my right? My r square, is it going to be in the denominator, the bottom, or is it going to be on the top, my numerator, if you follow the pattern? Bottom, right? Okay, so it's Q is equals to K divided by R squared. Okay, don't worry, let's practice a few more. Okay, let's get the hang of it. Okay, if you don't get it, don't worry. Okay, let's get the hang of it. Okay, come, try it too. Let's look at this together. Okay, let me try one more with you. Okay, let me try one more with you. P varies inversely to Q. Okay, P varies inversely with Q. So I will show you one more. So I will put P equals K. Okay, I always write the K first, right? So P equals to K, but because it is inverse, do I write it in my numerator or do I have to put it in the denominator? Which one? Emily, do I have to put it in my numerator or do I put this variable Q in my denominator? If you don't know, look at the previous example. My denominator. Okay, good. Okay, so this is going to be K over Q. Okay, I hope you guys are getting it. Okay, I try one more with you, and then maybe the last one you do by yourself. Can? Okay, R is inversely proportional to the cube of S. Cube of S is just S cube. Okay, don't confuse it with cube root. Okay, it is the cube of S. So, how are we going to write this into a mathematical equation? How? Let's find Danish. Help us out. Follow the pattern. Okay, Danish. How? R is. Tell me the first one. How do I write it? What is the first one I should write down? R. Good. Okay. After I write down R, is. Is what mathematical symbol? Equals. Okay, good. Then next one, K. Then, should I write it in my, where should I put it? My denominator or my numerator? Denominator. Okay. Okay, so it's SQ. Can, ladies and gentlemen? Okay? Okay, before you do the last one, what is the square root of f? Do you think square root, the word square root, do you think is this or this? Which one do you think? Is it the first one or the second one? First one, okay, by the exam, a lot of you will give me the second one, I don't know why. Okay, so, know this. Can you try this by yourself? Try this by yourself. Okay, I'll give you guys about maybe 10 seconds for you to write it down. Okay, yes. After which, Sharon will help me answer this question. Alright? Yes, correct. Okay? After which, Sharon will help me to answer this question. So prepare for it. Huh? Yes? Yeah, correct. Okay, come, Sharon. How am I going to write this? D is inversely proportional to the square root of m. So how are we going to write this? D equals K divide by? Yes. Okay? Good. Okay, I think some of you are slowly getting yes, honey. Okay, come. You can just tell me you need to go to the toilet. Alright? Okay. Come, can we look at the next one? Now, the next one is going to be very similar to how we have been doing direct proportional question. Okay, Junsi. Okay, come. Okay, I know you guys are feeling very tired. Today is a very short day. 1:50, you are coming to the end already. Okay, it's really coming to the end already. Alright, let's look at the next one. Okay, now if we know that Z is inversely proportional to T. Okay? First thing first, let's write down the mathematical equation. Alright? So we know that my Z is equals to K T over T. Okay, that is the first thing that I want you guys to write down. Okay, because I know that Z and T, they are inversely proportional, so the variable T must be in the denominator. Okay, must be in the denominator. That is the only difference. Alright? Next, the question will always... Tristan. Okay? The question will give you information to calculate the value of K. If you look at this equation right now, there are three things that you don't know. You don't know the value of C, you don't know the value of T, you don't know the value of K. In any equation, if you want to solve this with three unknowns, you need two of them to be known for you to calculate the third unknown. Okay? So we can now calculate the value of K. Okay? Because we know that T is 9. Okay? We know that T is 9, Z is 28. Okay? So what do we need to do here? We need to do something called substitution. Riley, can you help us out? Okay? If I have the equation Z equals to KT, how do I do this question over here? What do I substitute my value of Z as? Yeah. What do I substitute my value of Z as? You really? You read the top information first? 28. Okay, so I'm going to replace my Z with 28. My T is 9. Okay? Elvis, you have a lot to talk about, huh? Huh? Then you tell me lah. Okay, Elvis, can you tell me what is K? Huh? Wait lah. Okay, fine. I wait for you. Okay? Just tell me what is K first. I wait for you. How long you need? Okay? For the rest of you, can you think about this? If I want to calculate the value of K, how? Okay? How? Here is 28 is equal to K over 9. I give you a clue. If, remember we don't like fractions, right? This is K divided by 9. If you want to get rid of a fraction, what is the opposite operation of divide? Times. So can you think of a plan? Okay? How can I get rid of this 9? What do I have to do to both sides? Times 9. That might be a plan. Elvis, can you carry out the plan? Find out what is K. Okay, so what is K? Yes, Elvis, staring at the calculator for so long. What's the answer? Huh? 34 point something. Hello? Can you look up here? Elvis, the plan is to multiply both sides by 9. Okay? Why do you want to do that? If you multiply by 9, here, as well as the left and right, the 9 and the 9 can cancel. Correct? So if it cancels, you are just left with K. So what is this? Can you enter? Elvis, can you help us out now? 252. Thank you very much. Okay, so you get 252. Okay, hey, listen up. Whenever it comes to inverse proportion, many of you get stuck here. Okay, because you don't know how to calculate the value of K. Remember this, ladies and gentlemen, we don't like fractions. Okay, if you don't like fractions, you just multiply both sides. Okay, to get rid of the fraction. And, okay, so once we get the value of K, we substitute it back. Similar like how we did direct proportion. Okay, so we're going to get Z is equals to 252 over T. Okay, that's what we're going to do, yes? Emily, 2 minutes maximum. Okay, and step 3, now they want us to find the value of Z when t is equals to 12. Okay? So find the value of c when t is equals to 12. So how? Substitute, right? So we're going to substitute it in. 252 divided by 12. Use your calculator. Okay? 252 divided by 12. That gives me 21. Okay? Okay? Yes. Why I get 12? Or where I get 12? Good question. The question really says, what is the value of c when t is equal to 12? So in your equation, this is your original equation, right? So you just need to replace, substitute the value of t as 12. Okay, good question. Alright, let's move on. Okay, I'll ask you later. Okay, work example number 4. Okay, work example number 4. Can you look at the next one? Okay, the first thing first, they tell us that P varies inversely with Q. So in the space that is provided over here, I want you guys to write down the equation. How do we change this mathematical statement into a mathematical equation? P varies inversely to Q. Okay? So come, let us get someone else to help. Ashley! Yeah, how do you know I was going to answer? Okay? Now, P varies inversely with Q. So how? Yeah. Okay, so P is equals to K over Q. Okay, so this is the first thing that I need to write down. Always write this down first. Okay? What other information is given in the question? They tell us that P and Q have a corresponding pair relationship, right? They tell us that when P is equals to 4, Q is equals to 15. Okay, so this is the next information that is given to us in the question. Okay? Once we know this, step 1, find the value of K. How are we going to find the value of K? Yes, come. Okay, come, do it. Okay, so you say that P equals to K over, what is the value of my Q? Look here, what is my value of Q? 15. Good. Okay? Yes. Okay. Now, I'm going to teach you guys one more method. Okay, this method actually it's not new lah. I taught you guys before lah. Okay, to find the value of K, right? Actually, you can do something called cross multiplication also. Okay, I think a lot of you prefer that one. Okay, so if you want to find the value of K over here, you can express both sides as a fraction. So the 4, can you express it as 4 divided by 1? Okay, because 4 divided by 1 actually gives us 4. I'm not changing anything. Alright, the next thing, if I want to find the value of K, I can do something called cross multiplication. You can draw the cross. Let's follow the arrow. So I'm going to get 15 times 4 gives me 60 is K times 1 gives me K. So therefore K is equals to 60. Okay, so there are many methods that you can use to find the value of K. If you prefer to multiply both sides by 15, it's also okay. I know some of you prefer that. But some of you prefer to use cross multiplication, go ahead. Okay, you will get the same answer. Okay? Can any questions? Okay, if not, wait. Okay? If not, let us do the next step, express P in terms of Q. Now we have found the constant K. Constant is something that doesn't change. We can substitute it back into the original equation. Okay, so we are going to get P is equals to 60 over Q. Right, can you please quickly write it down? And can you do the last step by yourself? Okay, yes? Done already? Yes, correct. Okay, correct. Yes. Can I go back up? Absolutely. Okay? Can you guys try the last one? Okay, can you find the value of P when Q is equals to 6? Yes. Yes. That's correct. Juniors, you have to sit down. Hey, this one don't need calculator one. You can use mental. Can use mental. Okay, come, Chunfeng, help me out. So how do I find the value of P? P is equals to 60 divided by what? 6. So 60 divided by 6 gives me 10. Okay? Can you guys check your answer? Do you guys get 10? Elvis, I'm here. I'm not at the back. Okay? So the answer is 10. Okay? Not too difficult, huh? Not too difficult. Okay? Priya? Are you still with us? Okay, come, try it for. Now I take off the helpers. Okay, it's like when you learn how to ride a bike, right? When you first learn to ride a bike, you have a bike with 4 wheels. Okay, I'm going to take off that 2 wheels. Okay, let us look at the next one. How are we going to do it together? Okay? Okay, come, next. Okay, try it for. Y is inversely proportional to X. Ladies and gentlemen, Y is inversely proportional to X. How am I going to write it down in a mathematical equation? Kam-sam, help me out. How am I going to do this? How? Don't just smile at me, Come help me out. Y is the easiest one at the start. How? Y equals to K. I give you 2 options. Is it Y equals to K times X, or is it Y equals to K divided by X? Divided by X. Okay, if it's times X, what does it mean? Anyone? If it's Y equals to Kx, what does it mean? Anyone remembers? Directly proportional, thank you very much. Okay, so it's inversely proportional, that's why the X is in the denominator. Alright, so that is the first thing I do, I write down this equation. What information do I know? I know that when my Y is equals to 5, my X is 4. So, what is the next thing that I should do? Okay? Actually, don't say anything. What is the next thing that I should do? What is the next thing that I should do? Actually, substitute. But what is the purpose of you substituting? What do you want to find? K. Okay, great. Can you guys try now? Can you find the value of K by yourself?
I love K.
Some of you found already, right? Okay. So, if I substitute in, what is my value of K? Okay, 2 different methods that I've shown you. Either you cross multiply or you multiply both sides. But you should come to the same value of K. The K that you calculate should be the same as the K that your friend calculated. If it's different, it means that something went wrong already. Okay, because K is a constant. Okay? So it shouldn't change. Alright? Yes, Felicia. Correct. Okay. Okay, yeah, go through now. Correct, guys, correct. Okay, so what is my value of K? I can cross multiply in this case. If I cross multiply, I know that K is equals to 5 times 4. Yeah, it's equals to 20. Okay, so I have found my value of K. So for my part A, they want me to find an equation relating Y and X. So Y is equals to 20 over X. I replace the variable, not the variable, the constant K with 20. Okay, I replace the constant k with 20 over here. That's all. Okay, that's all. Alright, let's look at part B. Let's look at part B. Find the value of y when x is 10. Okay? Find the value of y when x is 10. We already have the equation. Y equals to 20 over x. So when my x is 10, what is my value of y? Okay, some of you will answer already. Freya, come, help us out for this one. When my value of x is 10, what is my value of y? I already got the equation out for you here already. So what do I need to do? Don't look at me like that, I'm very scared. Substitute, yes, I love that word. Okay, substitute. Okay, what do I substitute? 10, which variable should I replace? X or y? X. I replace x with 10. Okay, good. So I replace the x with a 10, so what is my final answer? 2. Okay, so my y is 2. Great. Okay, wait for juniors to come back first. My last part C, find the value of x when y is 8. Y is 20 over x. So when my y is 8. Okay, juniors is back. You can take the pass from him. Okay, which variable should I substitute? Y. And I replace y with 8. Okay, so I'm going to get 8 is equals to 20 over x. Then this case, how? How to find the value of x? How? I tell you again, two methods. Either you multiply both sides by x or you cross multiply. Okay? The method still works. Alright, this one I show you guys. Okay, so please pay attention if you don't know. I change this into a fraction. I cross multiply. So I'm going to get 8 times x give me 8x is equals to 20. So x is just 20 divided by 8. So what is 20 divided by 8? 2.5. Alright, so this is my answer. Can you try the next one totally by yourself? Okay, can you try the next one totally by yourself? The try 5. Okay, come, we are almost at the end already. Okay, we are almost at the end already. Okay, you gotta try by yourself, huh? Direct proportion, indirect proportion is not that difficult. Okay, I know some of you get very scared when you look at problem sums, but you break it down slowly. Okay, break it down slowly. What is your step 1? Step 1, find, change the mathematical statement. Problem sum is all words, right? How do you change the words into mathematical equations? Then always remember, find k first. Okay? Step 1, find k. After you find k, substitute back and then answer the question. Okay? Come, try by yourself.
Give me my calculator back answer.
Come, Julius. What's the first thing? This one. Read the question, convert it into a mathematical equation. Try. Yes? You are stuck?
Wait, stop.
Okay, you found k, substitute k back. So answer the first question. What is the value of p?
Wait, what? Wait, I don't understand. Hey, there wasn't food in my bag. Never seen. What is this? another way to say this.
Yes, can you please keep that? Okay, for those of you who are really lost, I help you out on the first step. P is inversely proportional to Q, so you should be able to write P is equals to K over Q. That is your very first step. Okay? And then you should find the value of K. They say P is negative 8, K over 3. Cross multiply, K is equals to negative 24. I stop here. You should be able to continue from here. Okay, I already found you the value of K. Okay, so you should be able to answer the question. Okay, for part A, yes.
Negative 24.
Yeah, correct. And you guys got to try, don't just wait for my answer. Okay, you really have to try.
Teacher, am I correct?
Yes, correct. Yes. So you know your from right now equation. What's the equation? P is equals to
Negative 5.
now we have you want to find the value of Q. No, when your P is 16. So find the value of Q. Find the value. Okay, cross multiply. Yes. Okay, come, let's go through this question together, and maybe I get some of you to help me out with this one. Kenneth, can you help me out with this one? Okay, find the value of P when Q is negative 4.8. So the first thing, I've already found my value of K. I know P is equals to negative 24 over Q. So what is my value of P when my value of Q is negative 4.8? 5. So you substitute it in, right? Okay, so good. So you substitute the value of negative 4.8 over here. You get 5. Okay, so that is the first part. To do part B, you rewrite the equation again. P is equals to negative 24 over Q. And now you look at the information that is given to you. P is 16. So 16 is 24 over Q. Now I want to hear from some of you. How are you going to find the value of Q? Because my Q is in my denominator. Okay, so how? Daryl? How? What is your strategy? What is your plan to actually find the value of Q over here?
Cross multiply.
Cross multiply. Okay, good. So if I cross multiply, I'm going to get 16Q is equals to negative 24. So what should I do on both sides? Divide by what? 16. Okay, good. So my Q is negative 1.5. Alright. Okay. This is 24. Alright. Okay. Let us do one last question. Okay? Can you look at the work example number 6? Okay? Can you look at the work example number 6? I'm going to do the first part with you, and then you're going to do this whole question by yourself, and then we end off today. Okay? We end off today. Alright? Okay. Come, let us look at this question. This one, they tell us, let's read the question together. For a container with a fixed volume, the height h and the square of the base radius. Let's pause for a moment. What is the square of the radius? How do I express this? The square of the radius. Chun Feng? What is the square of the radius? I give you two options again. Is it this or is it this? Is it the first one or the second one? Chun Feng? The second one, sure? You confirm? Really? No, don't look at people. Is it really the second one? No? Hey, come, Chun Feng, be confident. Yes or no? It is, okay, you are right. It is the second one. Okay, be confident. Okay, so this is the square of the base radius, alright? So in other words, I know that the height is, juniors, help me out with this one. How do I convert this into an equation? Be serious. Okay, how do I convert this thing? H is inversely proportional to the square of R. Okay? So H is equals to, there's always a K, right? The K over? Don't need. Okay, just K over R squared. Okay? If you want to write 1 over R squared, then you also can. Okay, you can write it as K1 over R squared. Okay, but it's not needed. Alright? Okay, now that you know this, can you try this question by yourself? Can I give you guys 2 minutes to do by yourself? And then I go through and I promise you we end the day here. Alright, that's all. Okay, we end the day over here. Alright, yes.
1A or A0? A0. Oh, right. What's R?
What is the find the height when the radius is 4. Find the radius. Find the height when radius is 4. Okay, I know a lot of you want me to check answer. Just hold on first. Okay, just give the rest 1 more minute. Okay, let's give the rest 1 more minute to find what is the answer. And then we go through together, alright? And then we end the day. Yes. Just come back from jail, right? You want to go back in now? Yeah, come. Isn't it good to be out?
I'm on probation.
Yes. So next one, find the value of K.
Is it 1 to 8?
I don't know. I haven't tried that. But sounds correct. Sounds like a correct number. Tristan, are you done already? Can you quickly do? Come, last question already. Okay, we are almost at the end.
This one is the last question.
For today, look at the time now.
No. Okay, this one here is for this one. This one here is for here. Really, man? Yeah. So the last question is
Sharon, come. Okay. Come. Focus. Now, let's go through this question together. First step, find the value of K. So, juniors, sit down. H is equals to K over R squared. I know that when H is 8, my R is 10. Okay, so when this is, I just need to substitute it in. Okay, so therefore, cross multiply, my K is 800. How many of you managed to get 800? Can I have a show of hands? Okay, that's awesome, that's good. Okay, thank you very much, put out your hands. Okay, after I found my value of K, I substitute it back. H is equals to 800 over R squared. And then I answer my question now. What do I want to find? They want you to find the value of H when the value of R is 4. Okay? So if you do a substitution over here, H is equals to 800 over 4 square. What do you get? Huh? 150? Oh, 50, yeah. Let me see, yeah. 800 divided by 16, that gives you 50.
You got 200 instead.
Okay, don't worry if you got it wrong. Okay, it's important that you know where you went wrong.